Okay, this is Computer Science 230, Computer Systems Principles, and this is the second part about processes. Some of our objectives in this video are to learn about process-related functions, to learn about loading and executing programs, to learn about signals, and to learn about pipes. One type of process-related function that you often encounter is the sleep function. And the sleep function allows you to put a process to sleep for some number of seconds. So in this example, you can see the use of sleep by including the Unix standard.h file, which is where the definitions of sleep come from. And sleep will take as one of its parameters an unsigned integer for the number of seconds the process is to be put to sleep. And what this means is that the operating system will actually suspend the process and not schedule it to run on the CPU for however many seconds you pass as a parameter to the sleep function. When that time has come, the process will be scheduled for execution, at which point uh, the sleep function will return, and it will return a 0 if the time has elapsed in completion. So if, for example, in this case, 5 seconds have passed, it will return 0. Or it's going to return a non-zero value if a signal woke up the process. And so we'll talk about signals a little later. Another interesting function is called pause. And pause is similar to sleep in that the process will not be scheduled on the CPU. However, the process will not wake up or return like the sleep function does after some time period. Rather, it needs to be woken up by another process, again using this concept of a signal, which we'll get to in a little bit. And this function, the pause function, returns the amount of time the process was paused. And so what exactly does a shell program do? So when we're talking about actually running and executing programs and the operating system representing those programs as a process, which consists of the state of memory and the state of the machine, which is stored in the data structure in the operating system. How exactly is a shell program working? So when you open up a shell, a command prompt, and you run a program, what exactly happens? How does the shell actually run a program or execute that binary and have it be a running process? So it turns out that the shell is a special type of program. It's a program designed especially for running other programs, which is rather interesting versus other types of programs that you might interact with. The way we do this is to use a function called execv. And execv takes 3 arguments. The first 2 we are familiar with. They relate to the arguments that main is provided. So main being that function that is the entry point to our C programs, main takes an array of character pointers, which is essentially an array of strings, where its 0th element is the actual program that is being executed. Execv is similar, however, its first parameter is the file name, and then the rest of the parameters that are to be used to execute that program are stored in argv. The third one is something that we haven't seen yet, which is called envp. And envp stores environment variables, certainly in the same structure as the command line arguments, but it stores special variables that are part of the executing program's environment. And this is what that looks like. So in a typical Unix environment, you can print out the environment variables using printEnv, and that will print out all these key value pairs for the environment variables. And as you can see on the right, there is a data structure, which is essentially a hash table, which maps or indexes to these key value pairs. And what's interesting enough is it turns out that there's a more general form for main, as we can see here, where we have the int argc and the array of character pointers argv for the command line arguments, as well as the program and the 0th entry. And then there's a third parameter, which is the table of environment variables. So if we look a little bit deeper into how we store a program in memory and all of its parts, what we get is something that looks like this, where we have the bottom of the stack, which is a null terminated, where the null terminated environment variable strings are located. This is followed by the command line argument strings, which is followed by some unused space, which is more or less you can think of as padding. And then we get to the array of environment variables that actually point to the null terminated environment variables at the bottom of the stack. And as you can see, the nth entry is null. The reason for that is so that we can tell where the end of the environment variable pointers are. And then right after that on the stack, we have the program arguments stored in argv. And the last element in that array, argv, is also null, so that we can find or we can know where the end of that array is. After that, we have some other parts of helping the program run, dynamic linker variables, which I won't go into detail right now. Then we have envp, argv, and argc, which are the two pointers, one for the environment variable array, and then the next one, which is the pointer to the array argv. Then the last one is the actual integer, which is the number of arguments. And then finally, we have the stack frame for main. And that's all. That's how the entire program is constructed in memory, at least at the beginning of its execution. Of course, this is really just looking at the stack. We don't see a picture of the code or the heap in this picture. So how do we actually access environment variables? It's fairly straightforward. We can use the function called getEnv, which will return a pointer if the name exists for that environment variable. And we have setEnv, which allows us to set an environment variable with an optional parameter to overwrite it. And then we have a third related function called unsetEnv, which allows you to unset an environment variable, which of course returns nothing. And this C file provides an example, which I won't look at now, but you can download as part of this material. So what does a shell program do? Like I said, it's a special kind of program that runs other programs, and it combines both fork and execv. Okay, so if we flip over to here, we can come to this simple program called shell. And here you can see in this program, it's very simple. We create a new array for the new arguments that we will construct as part of our program. And we take the given argv and its first entry, and we're going to make that the 0th entry of the new argv. Okay, so our first argument to this program is going to be another program to run. Then we have a loop, which does exactly what it looks like. It copies in the arguments to this program and copies them into the arguments for our new program. Then here's where the magic actually happens, right? We have this conditional where we fork, which will create a child process. We check if it's 0, so we go into this code here. And then we call execv. We give it the name of the program. We give it the name of the new or the pointer to the new arguments and our environment variables.